Hello everyone. In previous videos, we used one cell with a turntable as our application background. In that cell, we have EStops, light curtains, and a gate switch. For the actuator portion, we have a turntable and the tooling system inside the cell. Based on those safety components, we introduced how we can set the safety input and safety output, the safety parameters portion, and sometimes we need to set a single logic channel, and sometimes we need to set a OSSD. From this video, I will use 3 videos to introduce how we can program the TwinSAFE safety program. So the first video, I will introduce how we can connect the safety function block to the actual safety hardware channel or hardware terminals. And second video, I will introduce the logic portion, how we can connect the safety input components and the safety logic, how we can control the safety actuators. So in this video, I will mainly focus on how we can connect the safety function block, for example, EStop, light curtain, and gate switch, connect to this function block to the safety hardware terminals. To program the safety logic, we need to go to the TwinSAFE Group 1, this.sal, this area. Double click. So it will shift to do this. By default, it will show one network 1 here. That is our programming page here. And on the right side, you need to switch to the toolbox wheel. It will show all the function block you can use. To check the detailed help of this function block, we can search the menu and name the TwinSAFE logic function block. TwinCat function blocks for TwinSAFE logic components. For example, for the EStop, that function block, or two-hand function block, it introduced what the detail of this function block. If we record our application case, so in this cell we have EStops, light curtain, and gate switch. So let's start to program the light curtains first. So if you look at the right-hand side, and to check out the function block for the light curtain, you won't find the light curtain function block. See here. So if you are the new learner or just start to learn the TwinCat or TwinSAFE system, you will feel very confused for here. Light curtain is a very typical function block, should be. However, you cannot find light curtain function block here. How we can do that? So let's go to that application menu. If you recall, you will find a clue, for example, for the two-hand, for the light curtain, or for the EStop, what kind of safety function block we can use. From this application guide, TwinSAFE menu. For example, for the light curtain, we go to this section, and we can see to program the light curtain, we can use, that is the machine monitoring function block. If we shift back to this software portion, we will use the safe monitor, this function block. Let's drag it here. So this programming area, the programming language we will use, that is a FBD language. In TwinSAFE system, it doesn't have a ladder logic to program the safety logic. That is similar as a Omron Sysmax Studio safety programming. They both use the FBD programming language. Because we have a vertical light curtain and a horizontal light curtain, so we will drag 2 function block here. And I will rename this function block vertical light curtain. So its interface, we will connect the physical channel. Personally, I will not directly connect this channel to the physical channel. I will prefer to connect one buffer function block here. It is named Safe Decouple. The functionalities of this function block is very simple. It just transfers the left-hand signal to the right hand. So usually I will use this as a buffer is the left hand, I will directly connect the physical channel. And right hand side, for example, if we name this, that is the interface. We will zoom it and put your mouse here, drag to this function block, like this way. Because in this system, for each light curtain, we have 2 channels. So I will connect the 2 channels to its monitor input 1 and the monitor input 2. And on its left-hand side, there's no way to drag this direct to this physical card. So firstly, we will name it. For example, that is a vertical light curtain channel A. And this is a channel B. We name this channel first. I will introduce how we can connect this name to the physical terminals. We finished the vertical light curtain. So let's drag another one, decouple here. This we named light curtain. Drag it, connect. And here we give a name. And in this function block, for both channels, if we right-click, select this, change import setting, we will see by default, both channels, they are single channel. But because this light curtain has 2 channels, so usually we will select this, 2 channels. From here, we can set the discrepancy time here. Usually, we set 200 milliseconds. That basically depends on your device you are using or the application, how tight safety you want to go. Usually we will set 200 is unit, that is a milliseconds. So once we select the 2 channel here, so after you click the OK, so you will see this 2 channel will bundle together. And 200 means the discrepancy time here. And this is the delay time, so means if it's from 1 to 0, the delay time that 1 will delay 100 milliseconds. The delayed output will go to that delay out. And from here, this monitor output that represent, so what the output signal of this vertical light curtain output after those channel as well as those calculation. We can give a tag here that name the vertical light curtain. Okay. So we finished the setting of this light curtain. Let's shift here. For the horizontal, is the same thing. So firstly, we bundle these 2 channels together, select the 2 channel and set 200 milliseconds. We named. So we finished the light curtain here. And next, let's program the EStops. For the EStop, we have a direct function block named Safe EStop. We will drag this EStop here. And the same way, I will drag another decouple here. We connect this decouple function block to this EStop, and we name this, it named MCP, Main Control Panel EStop. Maybe in your system, you have a couple EStops button in your system, so you can name function block EStop MCP, function block EStop in door switch or on HMI panel, right? In this system, we only have one EStop, which is on the MCP panel. So I named the FB EStop MCP. MCP means Main Control Panel. Interface EStop MCP. Right? We gave 2 names here. Those tags will connect to the physical terminal. So we will name this name this channel B. And same thing for the EStop, we can group these two channels together. So we right click, select this change import setting. So we will group these two channels together. For EStop, usually we better make this discrepancy time a little bit shorter. For example, 100 milliseconds. And this delay time, because for EStop, usually we want immediately to stop the system. So we want this delay time a little bit short. For example, just to give 20 milliseconds. And from here, EStop MCP. Okay. That is the EStop MCP button. OK status. Okay. That is EStop. And the next safety component, that is a safety gate. Let's find the gate. When you look at the right side, you cannot find the safe gate, the function block here. So same thing, we go back to our application guide. This application guide, we find the gate, what the typical function block we can use. So we can find this protective door function. Same thing, it will use the machine monitoring function block here. So we back to our software. We will use the same, this safe monitoring function block for the gate. So that's the EStop. Under the EStop, we program the gate. Drag the safe monitor here. And drag the decouple. Connect them together. Okay, so we will name this function gate cell. And this named interface gate cell. Okay, and the channel input, we give a tag here. This is the gate channel B. Okay, and same thing, change the channel. This discrepancy time, so usually we will set a little bit higher, 300 milliseconds. And this delay time, we can keep this default 100 milliseconds or a little bit higher. Gate, we call the gate cell. Okay. All right. If we zoom out, we have a quick review. We have a two light curtains function block here, one for vertical, one for the horizontal, and one EStop and one gate switch. Other than those safety components, we still have two turntable direction signals. One is a turntable at the A side, one is a turntable on the B side, like showing in this drawing. Let's program this. This table signal is the same thing. We will use this safe monitoring. So from here, we can tap in the tag. The tag will connect to the physical safety hardware terminal. For the gate switch, because for each sensor, it has two channels. We can use this buffer, we can use this decoupler function block as a buffer to group them together. For example, the first two channels, we connect to the A side switch. And the channels 3 and 4, we connect to the B side switch. A side. at operator, which means the side A facing outside, and this means table B side at operator. Interface table safety. So this channel, we name it table A side. Table A side at operator channel B. This is channel A. So those two channels will transfer to here and will transfer to this table A side at operator. Okay, and that is table B side at operator. So we'll named so we can see use this interface or named the safe decoupler. It can be used like a buffer and can be also used like a group. For example, if your system has 4 light curtains, all the light curtain tags, interface tags, you can group here and use this outside to transfer to different function blocks. So same thing, we will group this together. Turntable is at 200 milliseconds. And this B side at operator. Okay, we create a 2 light curtains function block, EStop, gate switch, as well as a turntable direction sensor function block. And after this, we still need to program one thing. That is the reset signal. That is the manual reset signal for the safety input components. Usually, we must use the manual reset rather than the automatic reset. Take the EStop as an example. So if the EStop, both channel already on, for example, this output already on, and once the EStop pressed, and the signal will drop, this output signal will drop. And after the EStop button release, both channel will turn on. But that time, without this restart signal, we want this output still 0 in safe state rather than go back to on automatically. If these 2 channels already turned on, and after we give a reset signal, and after that, our output will turn on from 0 to on, recovered. For each function block, which is used for connecting the input, safety input component, for this reset, we need to connect the reset signal to reset this function block after the physical channel signal recover. From the application wheel, the different function of the components, we need a different reset. Usually, we need 2 or 3 reset groups. For example, for the light curtain, usually if the light curtain break and recover to clear, we will use the palm out button to reset this function block and make this function block output recover to on. And this palm out button usually will be mounted near the part loading entry area. We can name safety reset group 1 palm out. We give a name palm out, which means if we press that palm out button, it will reset this function block. And same thing for the next one. And for the EStop and the gate, the reset signal for here, we will use one reset button on MCP as a global reset button to reset the function block for EStop and gate. Here we can name this reset safety reset group 2, and we call it MCP button. And we copy this the same to the gate here. That is for MCP and the gate switch. For the turntable, this turntable is a little bit special because turntable, it will work in every cycle. So that reset cannot be only controlled by MCP reset button or the palm out button. Basically, it needs to be reset by itself. From logic wheel, we can put a very simple logic, for example, channel A and channel B, and after that, put a TON timer, for example, 100 milliseconds, and then put a TP timer, give a pause, allows the reset go from 0, 1, go 0. And, for the table B side, I will use another reset. Safety reset group 4, table B. We create the reset group, 4 groups here. One group for the light curtain, one group for the global cell MCP button to reset, and another 2 groups for the turntable. Until here, we basically finished all the input this area. So next, how we can connect this safety tags to the safety hardware terminals. Our safety terminals are here, and how we can connect them to these hardware channels. So we need to use this. We drag the button, find out this variable mapping, click this. It plays a role to connect our safety tags to outside. So for example, we go to find the EStop function block and find this interface channel here. Those 2 tags should connect to the safety hardware terminal. So from this list, we can find out the EStop MCP channel A and B. They are here. To connect this tag to the physical hardware, so if we look at this, MCP channel A, it shows this tag connected this safe decoupler, right? And its name, that is interface EStop MCP DEC input 1, which is here. And this allows you to connect this tag to the physical terminal. Click this. Let's review all those tags. And from here, we can see very clear. This alias device, that is the alias device here. And we drag. This is all our function block output, all the signals we can connect. And you can use this checkbox to sort the group you want. And if we recall, following the join, so the EStop channel A and B, they are connected with the slot 2, the first and the second channel. So following this elect join, let's connect. So here we need to connect this. We need to connect the slot 2 channel A. That is the channel A. The input channel 1, which connect to channel A. Click. And next, channel B, we select the slot 2, channel 2. Once your channel already connected one tag, it will show like this. it shows a different tag icon here. So let's click this channel 2. So next, we can follow this way. For the slot 2, for the gate switch, we will connect the slot 2, channel 3 and 4. Gate switch. Let's find out the gate switch. From our logic, gate switch. That is a gate cell channel A and a gate cell channel B. They are here. Gate cell channel A. Let's connect the slot 2 channel 3. And gate channel B. Connect the channel 4. Okay. So we finished the slot 2 safety terminal. Continue. So on the slot 3, the first 2 channel, it connect the vertical light curtain, channel A and B. That is a vertical light curtain. So, and 3 and 4, it connect the horizontal light curtain, channel A and B. That is slot 3. So we go to find our light curtain. Vertical light curtain channel A. It will connect the slot 3 channel 1. Vertical light curtain channel B. Connect the input channel 2. Horizontal channel A. Go to the horizontal. The horizontal light curtain channel A. Horizontal light curtain channel A, they will connect the channel 3. And channel B, connect the input channel 4. So next, let's look at the drawing. The slot 4 safety terminals, the first 2 channels, it connect the table A side, and 3 and 4 channel connect the B side. So we go to here, table A side. Table A side, channel A and B. So this channel A, we will connect the slot 4 input channel 1. And this channel B, A side, channel B. Click this channel 2. And B side, channel A, we connect the channel 3. And the left, B side, channel B, we will connect the last channel. So from here, we can see all those physical channels already connected with the tag. All right. And one more tag I want to explain a little bit more. That is, when we click this, here it has one alias tag here, error acknowledgement. If we look at this table, this error acknowledgement in, which connect the TwinSAFE group, this whole TwinSAFE group 1 error acknowledge, which allows this signal to acknowledge all the error inside. Where is this error acknowledge? If you shift to this group ports, if we shift to this group ports, we can see this error acknowledge that connect this group port underscore error acknowledge. This is a safety internal tag here. Is already connected by default. But which signal can control this? That is this error acknowledgement in here. And where is this tag? It is here. Error acknowledge this. After, I will explain how we can control this tag. So from here, we connect all the input cards to our input buffer. And in next video, I will introduce how we can connect the tag to the safety output hardware terminal channels. See you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe. See you in next video.